May I announce Thomas and Rico?
We weren't done yet. Want to do like a Steve Ballmer entrance where we run in and everyone? No, no, thank you.
Go ahead.
Steve Ballmer.
Yeah.
I've never heard of him.
What did
Steve
you do?
Ballmer, anybody? Anyway, so good evening or good afternoon. It's a pleasure to see you all here. It's such a beautiful event. I'm not really sure if all the user groups are happening in such an awesome place. Thanks also to organizers who gave us this opportunity. All the user groups are like this? I'm just asking. You know, there's also after party. Oh, dear. Anyway, so it's a pleasure to be here, and today Enrique and myself, don't see on my phone, right? We will do some crazy stuff as long as the computer is running. Of course, if the computer is not running, then we have a data center right here, right?
We have an IT guy in the crowd.
Yeah.
Who can help us out? Yeah.
Okay.
Cool.
Are you ready?
I think if we have some power, we're all good.
You want some stickers?
We got stickers. So the main takeaway of the session today should be they got stickers. They're awesome stickers. Yeah?
Awesome.
Okay.
Awesome stickers.
We were supposed to give them away at the end of the session.
I'm sorry. I'll start with the jokes in between. So
Yeah. Now people can just get up and leave because they got what they're paid for.
So one for you.
So Tomas and I are both crazy data scientists.
That's like the Pope, you know.
It's like our little hobby project. In the real world, we also have to do some work to be able to do some crazy data science. I'm a data and advanced analytics consultant at Data Masterminds. And Data Masterminds is basically a company that specializes in helping customers on their entire data platform. So from storing data inside the database, tuning queries, to doing advanced analytical stuff on your data. I'm an MVP, an author, I wrote a book. I'm obviously a speaker, and I have a blog, and some contact details are on the right, if you want to know them. Who's that guy, by the way?
I don't know. Sorry. Was that a line?
Yeah, sure,
sorry,
yeah.
that's me, yeah, sorry. With the beard. My name is Tomáš Kaštruň. It's hard to speak about myself. So I came from Slovenia. Anybody knows where Slovenia is? All right, Andrew. So it's a tiny country somewhere in between. If you go to Croatia, you probably would pass Slovenia. So. I am also data scientist for the past, 20 years. Being and doing BI development, part of crazy data science, I like crazy. Microsoft MVP, and also author of a couple of books, articles, speaker, and a blogger. So,
Cool.
and yeah, some contact information as well, Twitter handle and email and stuff like that.
So why crazy data science? Well, basically, we created crazy data science like a year ago when we were at a conference in Slovenia. And we're both into data science, and we wanted to talk a bit about data science. And we were like, how are we going to, or let's say it a bit differently, we were kind of tired of doing the same statistical explanations over and over again, and we were like, we need to have some more fun into it, because...
I thought you were in Germany, sorry.
No.
No, okay. Sorry.
We were in Slovenia.
Okay,
Okay, yeah.
So I thought we were drunk.
Yeah, we were definitely drunk. But we were like, okay, how can we, this complex field of technology and all these methods and techniques that are part of data science, how can we easily transfer that to people that don't necessarily work in that area? And we were like, yeah, what would happen if we make like a silly example? Like, for instance, what would happen if we show people how you can find Wally? Does everyone know the Where is Wally books? How you can use machine learning to find Wally. We also did, at Slovenia, we did how many schnapps can you drink until you fall over?
Schnapsometer,
Yeah,
it was called.
the schnapsometer,
Yeah,
yeah.
something like that.
We actually, when we tested it, our accuracy was very good, so it was very impressive. But you know, funny things like that, so it sticks a bit better. So that's our main goal, to basically show you some crazy data science, which shows you real methods and techniques that you can basically apply on real world problems, but we apply them on issues that aren't like really that important. We could have organized an evening like, okay, we're going to show you how to create a deep learning model that solves the world's health problems or stops world wars and everything, but that's a bit boring. So we were like, yeah, we're gonna do something else, we're gonna start a metal band.
All right.
So Metallytica, we really were prepared, right? Do you guys like the t-shirts? We even have tour dates on the back. And we're giving one away today. So we're gonna tease it already for a special assignment.
Yeah.
We were allowed to do that by the lawyers, right?
Yeah.
Yeah, okay, cool. So we decided, okay, let's do all that crazy data science stuff and let's make it like a team evening and talk about doing it with metal. We're gonna do all kinds of crazy experiments and the main theme is metal.
Anybody for metal, but not as a material, as a music?
Yeah. Okay.
Okay.
Is there anyone here who doesn't like metal music, by the way?
Anybody likes New Kids on the Block?
Shakira?
Yeah.
Okay, cool. I think we're good. Yeah. We did all the important stuff, right?
Yeah, sure. I think, yeah. Okay.
All right, cool. So we're gonna end up like this at the end of the evening. Let's go.
Okay.
So you need your laptop.
Okay. Do I need it?
I don't know.
We'll see.
We'll see.
So first of all, when starting a band, anybody was in a band? All right.
Rock on.
So the most important thing of starting a band is what?
Beer.
Groupies.
All right, groups. Whoever said that?
Yeah. I'm gonna write that down.
Where's the? Okay. So groupies. Okay. So what's next? Let's not focus on groupies.
Room to play.
Sorry.
Room to play.
Room to play. Okay. What's next? Oh, good point. Yeah, we have the room to play here. So every band has what?
A name.
A name. Ah, who said that? Who said the name? All right, you get a Metallytica sticker.
It actually helped. We said we're gonna give away a t-shirt. Everyone's like, yeah, we're gonna help you
So
out.
to warm you up, you know.
Yes,
so-
awesome. Thank you.
This is the way to go, people.
So
One
yeah.
stickers, you can upgrade to a t-shirt.
So we need a name, right? Okay. So first of all, I hope you can see it. We need a name. What we end up is wacky band name generator, as silly as can get. What I'm gonna do is, just for the demo purposes, I have it here in my reporting service.
Oh, I thought it was Power BI.
Yeah, it's Power BI. I get some probability and some interesting names. Okay. So let me know if the name of the band sounds good for you and we can stop.
I like this one. Royal Whiplash.
Royal Whiplash, put it down. So
Yeah.
we have a name. Okay. So how we did this? Anybody interested how we did this?
Yes.
Yeah. Okay. So first of all the data for today's session is publicly available. So a couple of JSON stuff like that. I don't know what JSON is. What's this?
It's a fancy XML.
Yeah, fancy XML. Thank you. And some Wikipedia, and we get all the data right there. So that's about GDPR as far as we can go for today. What we did was we scraped a lot of stuff from the web, and we started playing with the data. So this, what you see, is just the end result. And then there is the probability. And then there is the probability to show you how good the name is. Okay, so I said the data is coming from the Wikipedia. So let's quickly jump to, I hope this is the right slide. I'll go to R. Anybody knows R?
Yes.
1, 2, 3.
A little bit.
Python, does anyone know Python?
Yeah. Also a little bit.
Okay, so what we did was we classified and played with the data. So there are a lot of bands worldwide. So we have the name of the, I don't know, like boy bands, girl bands, like Shakira bands and stuff like that. And we gather all the names and we flag those. And we learned the model. Either it was, in this case, neural networks, just neural networks. And what we did was we played absolutely with the combinations of all these words, saying, okay, what's good for you is good for me. And I have all the data stored in the SQL database. I'm using R, in this case, just for some calculations. Don't be afraid. For those who don't know R, R is open source, like Python. It is a statistical language for that kind of wacky and stupid purposes. Yeah. What I'm doing right here is I am creating a corpus of text that will eventually just tell me, in this case, if the name of the band is metal enough. In the reporting services, what I did was I also added the probability. Probability is just the output of prediction, telling me how true the prediction is. That's it. In this case, I was just flagging my data with zeros and ones. I'm gonna skip the training model because I trained. So I have two examples right here. I hope you can see it. So first of all, my favorite, strawberries. Probably you had it before. So I added sunflowers and strawberries and angel of death. Anybody rings a bell? Angel of death? There's a nod. Anybody else? There's a nod too. So angel of death is a famous death metal song by some band from the United States, right?
Yeah, what they're called? They kind of look like us.
Yeah.
Butcher or something.
Yeah, Butcher or something. Yeah. They did the running gag Sailor. Anybody heard of Slayer?
Usually someone in the room when we mention Slayer goes like, Slayer, but yeah. It's too much to ask, okay.
There's a second giveaway. Or should I give this?
No, not yet.
Not yet.
It's funny because every concert that I ever visited, I mean, like if you're in an Adele concert and you hear the background and it's quiet between songs, it's, I'm Adele. Here comes the next song, and you hear someone in the back screaming, Slayer! Always. In every concert, there's always that one guy.
There's always that guy, yeah. So I'm gonna play with that. So I'm gonna fill, so Angel of Death, and I'm gonna do the prediction. I'm not gonna go discussing the code. We can do that after. That's why I asked anybody for the group is or something. So we can do that afterwards. And of course, it worked before. No. Demo effect, sorry. Let's go training the model. No, doesn't work. Okay, anyways, doesn't work. It worked like 100 times before, just 10 minutes ago, and doesn't work. Anyways, the idea is, once I put the predict, now it says something is wrong. When I put the predict in, it will just evaluate, classify whether the band name is metal or not. And in this case, Angel of Death would come as the real name, and Sunflowers and Strawberries would come as a not metal band. But in this case, if we go back to the web generator band name, this is a little bit more advanced, not just telling you whether it is or it's not metal, it is also giving you the probability. So once we have the name, what else do we need in the report?
Yeah, we did mention groupies already, right?
Yeah, we mentioned groupies. What else?
It would be a good idea to know, like, how many songs do we need to write?
How many songs? How many songs? Yeah, that sounds kind of good.
You can see we didn't rehearse this, right?
Yeah. Anything else?
Maybe there is a special trick with song duration. Number of songs on an album.
Okay.
I'm just yelling random things.
Okay, so second of all, once we have a name, what we want to do is explore what's on the market, right? That's our duty. So again, I'm going to load some R packages. That's how R works. And I'm going to go on this website to get all the statistics about Slayer albums. So those Slayer fans, yeah. Those who don't know Slayer, well, they're American death metal. They're on farewell tour right now, right?
Yep.
So they'll probably dismember in a couple of months. So
Yeah, so then we can claim the name.
yeah, well, hopefully, yeah, because that is.
Yeah.
Anyway, so
Absolutely. The first one I wanted to pick, but I was taken.
it's not better. Mouse sometimes help. Doesn't work. Works. Okay. So I'm gonna get the data into my R, and I'm gonna do some magic tricks. Voila. And I can get the discographic. Still, this is not what every data scientist or what Robert explained beforehand. You know, usually not everything just starts with, you know, putting data into an algorithm and stuff like that. We need to do some house cleaning. So what I'm going to do now is simply just go through the data set and create a couple of different data frames. And I've added also the length of the albums, the number of the songs, which is already in my data set. And I'm going to get also some songs. Songs I have downloaded. Sorry, just the name of the songs and a couple of statistics of the songs I've also downloaded from the website and stored it into my SQL database. Why are we using SQL anyways? Oh yeah, because Microsoft.
Yeah, yeah. Yeah, because it's totally cool to store 128 rows into a SQL server, right? You did it. Oh yes.
Yeah, that's correct. Yeah. So first of all, I'm gonna do is I'm just gonna invoke ggplot, and I'm gonna see the length of the Slayer song. So this is the name of the. So these are a couple of abbreviations, just for the sake that not the text is jumbled. And there on the y-axis, there are the length in seconds. So we can see that. You know. What can you see? What can you tell me about this graph? I wanna.
It's not normal.
Sorry?
It's not normal.
Of course, it's not normal. Definitely, it's not normal. What else?
It's a range.
It's a range. That's true. I would say it's ugly, right? Well, we can see immediately that somewhere in between, there's a pointer somewhere.
Use the pointer.
Use the pointer. If it's working.
Have to turn it on.
Oh yeah, so smart. So somewhere in between here, I would say there's this golden cut. So around 2.5 minutes, 200 seconds, excuse me, 250 would be an average song length. So this is something we are trying to do now with the band, right?
Yeah.
2.5 seconds.
2.5 minutes.
200 seconds is
200 seconds. Yeah, that's a bit more than 3 minutes.
Yeah, 3.5. Let's put it 3.5. So it's not going to be a punk band, right?
No.
Punk bands usually have what? 60 seconds?
Napalm Death does 10.
And we're not going to
Seriously,
be
there's
Dream
a band
Theater,
with
right?
10 seconds songs.
We're not going to be Dream Theater, right?
No, we're not gonna over expand everything.
Okay, sure.
Then we would be like Metallica's last album, you know, just stretching. So 3.5 minutes is good for us.
Okay. And I'm going to do, and I'm also going to do a couple of different visualizations. And I can see the total length of each of the album stacked together with the songs. So immediately I can see the Rain in Blood. Those who are Slayer fans, I think this was their second or third album, not really sure.
Best album.
Sorry?
Their best album.
Their best album, absolutely, is the shortest one. So this is also something in a way of a formula, but we can see immediately that it's on. Somewhere in between here would be the mean, right? What do you think, audience? So that's 2,000 seconds. Wait. You're gonna calculate. Half an hour, yes. Okay.
30-minute album.
30-minute album. That's the formula. Okay. Yeah, I know.
There's already some magic here.
I mean,
you know a lot now.
I can do that like this, right? But nobody. That's even wrong. I mean, that is correct. It was we said 2,000, right? 60, right? I can do it like here, so it's exactly the same. So yeah, you can use R as a computer as well.
Calculator.
As a calculator, sorry, thank you. And your English is much better than my Slovenian interpretation of English.
Oh, thank you. Your Slovenian is way better than my English.
Today's session can also be broadcasted in Chinese, right?
Yeah, absolutely.
Okay, and I'm gonna do again some graphs because we like graphs, and this is another presentation without the songs. And this is this is the medium length of the albums. Something we already know. And if this does not explain enough, what else we can do? Statisticians or data scientists love box plots.
Oh.
Ah. So can anybody explain from the audience what box plot is? Box plot.
You can win a sticker.
You can win a sticker. Box plot?
It's the distribution.
Distribution, yeah, that's good. What a distribution of songs, length, songs.
Songs.
Songs. What songs and length?
The length of songs.
Length of the songs. Yeah. What does this lines represent in this so-called whiskers?
Median.
Mean?
First quarter.
Outliers.
Outliers. Awesome. Everybody knows everything.
What are we
Is it
doing?
really? Is it really mean?
Median.
That's right. That's a sticker.
Oh, yeah. Thank you.
It could be ordered like 2,000 of them.
So, because why people like this? Because it tells quite a lot, as the man with the sticker said. You get a lot of information from this little box. So let's focus here. So you get the median. What is median? Median is
The middle's number.
yeah, and you get third and first momentum. So you see actually distribution, and you also see the outliers or where the numbers or the values goes. And these dots are effectively those definitely outliers. So what do we need to do with the album? Yeah, we're gonna focus around here. So in this area, and no outliers. So no songs less than 1 minute, and no songs longer than, that would be like 65 minutes. So this data is basically grouped all together from different albums. And we want to know how the band, in this case Slayer, did on chart list. If you go to Wikipedia, you will also see that there is the information about chart list, and you can easily see. I'm just gonna load a couple of more. I'm loading too many libraries, I guess. You can easily see how the albums were doing on the chart. The problem is that you see when they were released and how far the album came to chart position. The problem with this is that I have wrong names, so I need to correct them. So what I did was I've done some house cleaning again in order to produce something like this. essentially the same data. I hope that the dots can be seen from the data as well. And this is the highest position. So bear in mind that the higher number means lower, yes. So the 0 or the 1 is actually what came on top of the chart. And this is, for instance, in this case there, we can see that how during the ages, so the albums are sorted by the year of their publishing. So you can see that it went all the way down. So with the age, they started to become better and better in terms of chart positions. So this is something we need to know, right?
Yeah, you're already pretty old, so I think we're
Oh,
good.
thank you. Thank you for the compliment. Yeah. So yeah.
You mean like the length that you're together as a band?
Yeah.
Oh, okay.
So in terms of being productive, in terms of albums, so don't give up too quickly and start working on new albums as well. So I'm gonna load some, again, 126, 28. And we're gonna see the name of the songs written by musicians. In this case, again, I am doing ggplot. And you can see, not much really, but you can see something. That Jeff Hanneman, may rest in peace, was the most effective artist, and the Kerry King, his hair will rest in peace, like mine, soon. Anybody know Kerry King or Jeff Hanneman? Yeah, probably you and somebody else. Jeff Hanneman passed away a couple of years ago, and that's it. So this graph is okay, but I want to do something better. I'm just gonna recreate it, the data set again, and what I'm gonna do now, I'm gonna flip in order to have something much more visible. So beforehand, now what I did was, if the name of the song was produced by two artists, what I did was I degrouped them and put them all together. In this case, you can see that Kerry King, the lead guitarist, had the most amount of songs that he played on. Quite
So
fancy.
it would be a good idea to have a guitarist write our songs.
Yeah, put it down.
Yeah,
Thank
that's
you.
important.
That's an important, yeah. And we don't let drummers do anything, and Rob Halbert, I never heard of him, but
He's from that other band, right?
from the other band. I don't know.
No idea. How does it go?
Yeah, okay, never mind.
And never mind. Guitar players, if you write a song as a guitar player, you are more likely to get a good song
Yes.
than a drummer,
Yes,
which just makes perfectly sense.
of course. So,
Any
and
drummers in the room, by the way?
Yeah.
Ah, ew. Poor guy.
and all I'm gonna do is number of words per each of the album. So yeah, again, I'm lacking access. Awesome. So yes, I like box plots. So you can see number of words per each of the album, and you can see World Painted Blood, I guess, was the before last album, and they were very much politically orientated and had to tell quite a lot of stuff, I guess. And if we focus on the first one, the good one, was actually probably the lowest in the median in terms of the songs in terms of the words per song. So we can say, we can say that around 200 words per song would be, I guess, what do you say?
Yeah, that sounds good.
Sounds good, 200 words, what do you say? I mean, not Rammstein songs, right? Ich mag, that's like 5 words.
Yeah.
Okay, and that's about it, I guess. This is what we've gathered about some cool Wikipedia statistics.
Important stuff, man.
Important stuff, yeah. And the next one would be, once we have all the statistics about the songs, I think we should start writing some songs, right?
Yeah,
What do you say?
yeah. Thankfully, there's only one drummer in the room, so that's gonna be no issue. Any guitar players in the room? Come on, don't be
Come on,
shy.
don't
There
be
are
shy.
people that play guitar. Nobody plays guitar? Oh man.
Awesome. We have a plan.
Probably a lot of keyboard players.
Keyboard players. Does anyone play keyboard? Don't be shy. No? So we've already discovered like the magic formula for writing songs, like the song length and all that information. So what's basically next is that we have to write some songs, right?
Oh yeah. Anybody good?
Writing songs?
The audience? No? Don't
No.
be shy. It's much easier to play guitar, right?
Or drum?
Drums, yeah. So if not, then we'll probably have to leave it to the computer, right, or something.
Yeah. It would have been so boring if data science wouldn't be able to help us.
Yeah.
Now, if only this would work. Something's happening.
It's happening.
Ah, beautiful trees.
Beautiful trees.
Not what we want. Duplicate. Ah, yes, it works. So what we're gonna do next is we could have sit down, like, you know, book a hotel room, book a studio, sit down, have a couple of beers, schnapps, whatever.
I'm not saying.
And and write some lyrics down and be very emotional about the way we feel and express ourselves through our lyrics. But again, that would be boring and we are very lazy. We would rather just drink beer and schnapps without having to think. So we decided why not, you know, borrow some lyrics from other bands and let a machine learning model generate lyrics for us. Sounds logical, right? So what I did here is I have various text files from 3 big bands, Metallica, Slayer, and Iron Maiden. Basically what a text file looks like is it's around 1,500 to 2,000 lines of song lyrics, which I painstakingly copy-pasted from websites into a text file. Because that's what you do as a data scientist. And we were like, okay, this is really cool, but we need to have something special. So I also decided to download all the lyrics from Nickelback and also throw them in there because, you know, you want to be special. You don't want to be the next Slayer or Metallica. So again, I'm going to import some libraries, just like Thomas did. And I'm going to import all those text files. The way that looks like is basically I put everything into the last data frame. And you can see there are almost 7,000 lines of songs here with which band they belong to. This is actually Creeping Death, all kinds of songs, and by the 4 bands I mentioned. So I'm gonna do some more analysis because, like I said, feeling and presenting yourself through your music is really important for us as artists. So we have to kind of discover, okay, what's the feeling we would like to show the world to be successful. We know how long the songs need to be, we know how long our album needs to be, how many words per song, but we need to give that feeling, that special vibe. So what I'm going to do is something called sentiment analysis. I'm pretty sure everyone has heard about that before. Basically, what kind of feeling does text give you? Is it a positive vibe or is it a negative vibe? So I need to do a couple of things, which Thomas named housekeeping. Basically, I need to do something which they call unnesting, which basically replaces the entire sentence and just splits the words up. And I remove all the stop words, because those aren't very useful. And in the end, we should end up with a lot of words, more than 3,000. And you see already that there are some words that are more popular than other words. Time, life, death. Oh, death, yeah. Die, blood, hell. All right, so, but like Thomas also did, this looking at this data is really interesting, but graphs are way better. So I'm going to show you a graph of this data. And basically show you for each band which the most popular words are. And I stacked them here. So I did some filtering. I filtered out all the words that didn't occur more than an X amount of time. And you can see that Ghana is really popular with Nickelback. Never gonna give you up, oh that's someone else. But also with Iron Maiden, which is very interesting. Time is apparently popular with every band, and the most important one, Yeah, is very, very popular with Nickelback. I would have expected that by Metallica, because James Hetfield runs on the stage and goes, yeah, all the time, but apparently not on their albums. The other words like death is popular by Metallica and Slayer. So this is interesting information. So these are good words. We need to have these words in all of our songs, basically, if we want to be successful. So is there a positive or a negative sentiment? So the way we can do that is we can do that sentiment analysis by loading a library. And in this case, I selected the Bing library, which basically probably involved scientists copy-pasted all kinds of words from the internet and gave it a number how positive or how negative it sounds. So if I say deaf, it probably sounds pretty negative for a lot of people, and he kind of figured out how negative and put a number behind it. Thank you, Mr. Bing. So what does that look like? And I've ranked with the most positive and most negative words. Love is very positive. Death is very negative. Die, hell, death. Pain is pretty negative. Sounds. Monster is positive. Yeah, I was surprised by that one as well. Yeah, I didn't really understand that. I don't know what Mr. Bing's hobbies were.
So I guess Master of Puppets would be.
Master of Puppets would be a very positive song. Absolutely. So, how we know it, the most popular words, but how would that kind of reflect on each of the 4 bands we selected? So let's look at the sentiment per band. And as you can see, and I can finally settle that old discussion we had, Tomas, because we always said, yes, Slayer is one of the darkest bands ever. No, Metallica is actually more negative than Slayer, but they are also more positive. So they go every direction. What's very interesting is that Iron Maiden and Nickelback are practically the same. So I don't know where that went wrong, but apparently Nickelback on average is pretty negative band. I was very surprised by that.
Surprised because you said Metallica is quite, black, but an album black. So.
Yeah, oh yeah, so that should probably be it. Yeah.
Yeah. It's very interesting, I must say.
Iron Maiden was, I expected Iron Maiden to be more positive and a bit of negative, but Nickelback, man.
Is there any hidden layers in this?
No, there are no hidden layers.
Nickelback are from UK?
Canada.
Canada.
Yeah, I would have expected the word sorry to come up.
Iron Maiden would be UK?
Iron Maiden is UK, yeah, so they're a bit more civilized.
So civilized Canada, UK, that would be
Yeah.
like one cluster and
Good idea.
can be, huh?
What I wonder is, why didn't you take Adele instead of Nickelback? Because
Yeah, we could have done that. We tried it with K3. And actually, when we did it with K3, it turned out that K3 was pretty negative as well. So, and this is science, people, so this is the truth. But yeah, you could have thrown everything in there.
So Adele would probably, the model would break because of the hello.
So this is all really interesting. So we kind of know, like, okay, what kind of sentiment do we want for our lyrics, and we also know, like, okay, which kind of words that Tomas wrote there do we want to include in our lyrics. But we don't have any lyrics yet. So to do that, we're going to step outside of R a bit and go into Python. Does anyone know Jupyter Notebooks? Really useful, yeah. So I got a Jupyter notebook here, which is really useful to step through each cell one by one and look at the code and explain what it's doing. And just like R, I have to import a lot of modules to do special things. And in this case, I'm running a module called Keras, which is basically a language to write neural networks. It's based on TensorFlow, and you can write neural networks here. We need this because we are going to create a very special neural network. And I've actually practiced this one, so I hope it goes well. We're going to train a long-term, short-term memory recurrent neural network. Was that right? No, that was totally wrong. It's good enough. We'll just call it recurrent neural network. What it can do, and the world's very excited about those networks, is that it can basically have a feedback loop in itself. So instead of putting something in, getting something out, this one can iterate in itself multiple times. So perfect for generating things like song lyrics and things like that, because I can basically train my model on, okay, here you have all the words from all these songs, and I want you to kind of compose sentences out of all these words that also make sense. So instead of just throwing all different words behind each other, I kind of want you to look into all the data I gave you and figure out what word orders make sense. So I'm going to need a couple of functions for that. And I'm going to need an input file. And I created one file called all lyrics that I copy-pasted every file into. And I'm going to define a model. So this is basically very simple, my neural network model that has a number of layers, and all of the special stuff happens at the LSTM layer. That's where basically the magic happens and where lyrics are generated. I'm going to compile the model, and I'm going to be lazy, and I'm going to load my model weights. The reason why I'm doing this is because training a recurrent neural network can take a long time. I've given him something like 40,000 different words, and I'm expecting it to know like what are logical word orders, what would make sense, and that can take a long time. I did 500 iterations, because you train it in iteration, and every iteration it learns a bit, it tunes its neural network weights, and it should get better. And that already took me like almost an entire night. Tomasz, yes?
Sticker question to the audience.
Oh.
How to speed up this?
Parallel processing.
Okay, that's half a sticker. Okay, more ideas?
Put it in the cloud.
Awesome. Who said
Yeah.
that?
This is all very
Cloud,
computational
first
heavy.
cloud, who said cloud? You again, come on. Man.
Sorry.
What I also could have done, do I get a sticker then?
Oh, yeah, of course.
Is train it on a GPU, because neural networks and, cool, thank you very much. Training those things on GPUs is very effective because of the way the GPUs work. And you can actually do that with the Keras and TensorFlow libraries. You can compile them on a GPU and make the train a lot quicker. And as always, the more data you have and the more your iterations, the longer it's going to take. So after 500, I quit because my results were good enough, and I saved my model to disk so I can show it to you right now. All right, so what I'm going to do is I'm going to call the function generate sequence, and that's going to ask of our model that we've trained on all those words, with all those iterations, I want you to generate me a sentence of words based on the first word being love. And I want you to generate 16 words. So what the neural network is going to do, it's going to take the word love, it's going to load it in the neural network, and it's going to kind of figure out what would be a good word to match with love. And after that, what's going to be a good word that would also make sense after the word love. The funny thing is, I never really know what happens when I let it generate, because it's completely random. So let's see what happens. Loved the land called Planet Doom, forgotten through death's ground, their treacherous headed sins strike defense years. If that doesn't sound metal. This one is actually pretty good, that one. I'm actually surprised.
I'll make a photo of that.
Yeah, we need to make a picture of this. Does anyone, by the way, know where RNNs are used for? Has anyone ever seen the clickbait headlines? Like Brad Pitt used this shampoo on his hair and something marvelous happens, click here to find out more? These are 90% of the time generated by models like these that basically combine words, because if you read, who would be interested in what shampoo Brad Pitt puts in his hair, right? But apparently somewhere a machine thought,
I would be.
yeah. Probably because you were the only guy, you were the outlier that influenced the model. But that's how they generate it. So let's go for another one, Faith. Faith was also very high. Faith outbought Madman too late. Oh, bold one. Bad one, years won't carries, never sends off. Okay. It's a bit, it doesn't do punctuation or anything, but we can make that work.
Smells like Nickelback, right?
It smells like, let's do Free. Free the Devil's Night of Hell. That's Slayer. And Light Me With It. That's for Follow, Go and Get Till Somewhere. All right. So those were the happy words. Let's do okay. I'm not done. All right. So let's move on to that.
Disclaimer: this is randomly generated right now. So
Yeah. That's why I said it.
Question. If you execute the same statement, it will be generate exactly the same.
It will now generate exactly the same because it's in my memory. I have to restart the kernel to do new generations. Yeah. So die by my hand. That sounds like Metallica. All before all, it is known man. Years think it's gone to a number. I am tired. Mine easy to cut. We can make that work. I think, right? Pain. Pain results in screams. Wow. Sounds logical. Bleed internal. We're not doing surgery here. And tonight, souls, 100 eyes, wolves bitter riding wolves. This is a good metal. We're gonna use that. Let's also do a Nickelback one. Yeah. Let's see. Yeah. Yeah. No, song is this friend to fit. Just it seems they have. Yeah. I'm talking quite moonlight walls. Does anyone else have a good word? Doesn't matter. We're taking.
try angels.
Suicide.
Angel suicide.
Try SQL.
Suicide. Suicide running, as if it were free. And this moment for you, you realize, begin prison coming back. Truth needed me. Okay. Someone else? This is your chance. Don't steal our lyrics, by the way. We're making images of this. I heard sequel. Yeah. Why not? You can write a song about sequel. Sequel, then it escaped. This lion man freed a hard time to tell judgment of hell, mandatory laughter. Story saying might fade. Oh well, that's pretty good, right? Awesome. So everyone understands how this works? This is useful, right? Especially for us, because we're not going to generate lyrics. We're going to let it train a bit more, add more artists in our data set, and let it completely generate complete songs for us. So this is definitely going to be super helpful. Any questions?
Excuse me.
Yeah.
Could you try one Chinese word?
I
I
don't.
never learned.
Uh-oh.
I just, I know you cannot type Chinese, but you can type pinyin, that's 你好, that is hello. Yeah.
Don't ask me how I know.
I never know that. that, I'm wondering,
Yeah.
what he is going to make.
Basically, you get the same sentence because those two words were never in the actual text. So it will revert back to a state where it knows, okay, I started with a word I didn't know, so I'll just chain these random words behind it because I don't know the input. So no matter if I put a word in there that isn't in a song text, it will always generate that sentence. So you have to be a bit careful if you are sure that you have practically every word you wanted to return. So
Go ahead, sorry.
we got all the information we need.
Can you do 200?
Can you do 200?
So we said that the favorite song is 200 words per song.
Yeah, let's see.
Let's start with that, yeah.
Good question, Thomas. You get a sticker.
All right. Beautiful. There you go.
Dragon sent horror. Feed him more.
It can be done, yeah.
Yeah, it can be done.
Can anybody sing in the room?
So something really cool is about the way these things work is someone trained an RNN on all the work of Shakespeare, and then basically told the machine, okay, I want you to generate a Shakespeare play. And they trained it for a very long time. They spent a lot of time tuning it, but it generated a complete new Shakespeare play that was basically complete in his style, so accurate that it can get. There's also a guy who wrote a number of Harry Potter novels using an RNN. So he basically wrote a book of Harry Potter with randomly generated sentences based on sentences used on in the actual book, which resulted in also very interesting sentences. With that, I think it's time for the break.
Yeah.
Because we all need a little bit of alcohol now, I think. And we'll be back in like 10 minutes, I think.
Yeah. Don't go away.
Don't run out. Keep an eye on that door. So we figured out a couple of things right now. We figured out like, okay, how many songs do we need to have? How should our album look like? We kind of figured out what kind of like feeling we need to give out as a metal band, and we figured out that negative emotions work really well. So we're going to use a lot of death and die and blood and hell and yeah.
And yeah. And love.
And we also generated some lyrics. So because we generated some lyrics from other bands, we also need something else that's also very important. Does anyone have an idea? We have lyrics. What do we need then? Music? Or
Song titles.
no, we need to figure out if we need a lawyer or not. And that's what Thomas is going to show you. But first,
I'm not a lawyer, so. Yeah, but first, fun fact. Previously, I forgot to show you. This is actually the death metal bands in the years when they were created, and you can see the total decline. And this is 2017, 18. None of the bands are actually emerging. So this is just a fun fact. Again, data available on Wikipedia. And you can see here some additional statistics. So these are the continents. So this is South America, Asia, North America, Oceania, and Europe. And you can see the first ever band and the last ever band created, what is the average, so the mean, median, and so on and so forth. Again, something data scientists will definitely do when creating statistics. So, if we need a lawyer, I think we do, because we've scraped quite a lot of data from the website, and we don't want Bruce Dickinson, who is an old guy, suing anybody. So the next demo is basically in SQL Server, and we will basically have the data in SQL Server, and we will generate the R script or Python in this case R script, but you can do it also in Python. We will create some procedures, and these procedures will create a model, store the model, and do the prediction of those models. So this is super easy. Imagine if you're in the enterprise like here today, somebody is producing the code and somebody is consuming the models, and then somebody at the end is saying, okay, we can and do the deployment of that model. So So how it is done? First of all, the data. We got the data from the website. So Enrique copied the data from the lyrics. He copied
By hand, of course.
by hand, yeah. So I did that the same. You know, data scientists are not always that cool because they do also some copy pasting. So first of all, the idea is generating emails. If we get a new email from a fanboy or from a lawyer, and we want to know if this email is from the lawyer or it's a fanboy email. The next, what we want to do with that is we want to classify it. Of course, we want to classify it and see, okay, if we need some immediate reaction or we can just save it for later or save it for the goodness. So the lawyer stuff is available on the internet, and so sort of like emails and fanboy emails also available on the internet. Where did I download it? From different forums, from different channels, YouTube, stuff like that. Again, copy pasting, putting everything together. Python code, those who use Python, beautiful soup. Yes? Say yes, say no. Yeah. Beautiful soup is a beautiful library, as the name suggests, beautiful. And it is very useful for sort of extracting parts of the, if you do it like this, email or something like that, extracting the subject, the title, etc., etc. Once I had all the tags that I needed, so the subject in my database, so the data resides in my database, then I will start doing what? First of all, again, bunch of libraries in R. I will just quickly go through the codes. I will not bore you with any more details. I need some house cleaning. So I get the data from email, from SQL. Then I do probably the same as Enrico did before. So I will create a corpus of all the text, and I will do some house cleaning, remove any kind of words that are unnecessary and stuff like that, stop words. And then I will create a matrix of those words. And what I'm going to do next is I will try to predict those words. But first, I need to have a model. And my model is right here. So this is generate model, as the procedure name suggests. And what I'm going to do here is essentially I get the data in, I do the cleaning, and I will generate the model right here. So I'll probably just make it a little bit bigger. So in this part, I create a model. First of all, I train it, check the accuracy, and then I can store a model as a serialized binary string in the database. So those who are either coming from some corporate environment or something, you want to do some classification of a text, this is a way to do it. So you can import everything in SQL. Note, all the code needs to be valid. So this is Management Studio, SQL Server Management Studio, which I believe you all know. If you copy paste a Python or R code inside, you will get, and if it's not valid, you will get an error, and we don't want that. So what you do is you either copy paste the code in your R or Python environment, you can check and validate the code there. Once you have that, you can just copy paste it in the SQL Server, and that's it.
There's a lot of copy pasting involved being a data scientist.
Yeah.
Yeah. And Googling.
That's true. Yeah.
And Wikipedia as well. Yeah.
2016, data science was considered sexiest job.
Yes. Yeah.
2015, not sure. And then last year I read that,
It's not
that
sexy anymore.
Yeah, not that
I'm
sexy.
gonna do something else then.
Because it involves house cleaning and copy pasting and stuff like that. So.
Does anyone need a BI developer or something?
Anyways, short story, so long story short, at the end, basically, I end up with a couple of tables. So one table is where my model is, where my models are. the other table is where my data resides, and I have a bunch of procedures, just like that. I mean, it's not that super easy, but it is easy.
But you're all doing this inside SQL Server,
Yes.
right? So
Yes.
this, in the previous example, you saw us write our code in RStudio, get data from SQL Server and do it in R. This is all integrated in SQL Server. So you can directly from your SQL Server environment do all this code, do predictions, do model training, and even scoring on your SQL Server.
If your model is residing in, somebody said Azure, or if you want to do some parallel computation, you can also do that in SQL Server. If you want to do some distributed and computational, distributed in parallel computations, there are a couple of libraries available from Microsoft, both for R and Python, that can do that. Otherwise, it is a bit nifty getting data in, especially, the code in, especially because the code needs to be validated. So, long story short, I end up basically with this. So you can see I have 3 procedures, and the last one is basically predicting my text. So this is the text, brief by Jeff, is awesome, and email team confidential, something like that. So, and then what I will do is I will classify. So the model is stored in the table. You can check. Sorry, I need to connect. Sorry.
Which databases?
Too many databases. So this is my model. Nothing really interesting, but as I said at the beginning, it is stored as a serialized model in the database. So this is a table, and this is our binary max for those who are SQL guys. And this is my data. I'm just going to go back. And you can see I've immediately flagged those passcodes so that they are in order classified, and you can see these are the documents we get from our lawyers that we need to pay special attention. And 140 is something which is coming from our fans. This one, 21, is particularly interesting. Jeff never dies.
You did.
Yeah, he did, unfortunately, yeah. And trying to find the one with Rip Jeff Hanneman and Rip Kerry King's hair, but probably
52.
52. Oh, right, yeah, that's awesome. Kerry King. So, Harry King, for those who are not Slayer fans, he's bald. He got bald during the ages of Slayer being active, and so these are the fan mails, or maybe not even fan mails. Anyways, I ended up doing this. So I have models stored in the database, I have data stored in the database, I have 3 procedures, one for creating a model, one for scoring, and one for predicting. And then I simply push F5. And a couple of seconds later, both models, so both these texts will be scored, and that's it. It will take roughly, I don't know, 15 seconds, 16?
Yeah, it needs to start a Launchpad service for the integration. And the first time you do some external scripting with R, it has to basically load the entire Launchpad process into memory before it can actually do something with your model or run your R or Python code.
Are you running this on a virtual machine, Andrew?
Is this written?
Yeah, if I hide it and tell you it's a virtual, will you believe it? No, it's running on this computer, so it's
Okay,
just a
yeah.
demo, and yeah. So in this case, I'm just going to put it like this. So remember, 140 was our fanboys, right? And 120 was some lawyer stuff. In both cases, the text predicted the correct classification. So again, we are predicting those 2. And the first one should be 140, and the second one should be 120. And that's it. Fun fact, if you have, the more words you have, the better the model will predict. The more correct will be. In this case, I am using a GLB, and I've just created very simple model. So in order for the model to be faster, so this is the part where you define the model. Yeah. And if I say number of repeats higher, if I set this higher, and if I change the method, then the model would also need much longer to train, and the predictions would be much better. So once I have those procedures, I can easily do anything with those procedures. So in this case, what I did was, of course, I put it in reporting services, and I can just select any model and put any kind of text string, and the reporting services would return the prediction from my inputted text. Simple as that. So now we have covered the lawyers and the lyrics.
Yeah.
And what else?
We're missing one more thing.
Groupies?
So this is probably the most important thing, so that we know we don't get sued with our lyrics, so we don't quickly die as a band. But I heard it before. We need one more thing. That's music, right?
Music.
So we were going to bring a band here, but only the guitarist came, and then he ran out after we started. So there is no music. So we have to figure something out how to do that. To let a computer generate metal music, we tried, but it's pretty complicated. So we kind of went with something in between, which is almost as good, I think. Oh, yeah. Awesome. And then we're going to show you.
Yeah, we're going to show you something. And then I think our metal band has all the framework, but we still like something, right? It's in the slides, or?
Yeah, of course. This is kind of, all the people are wondering, what are they talking about?
Yeah.
Has anyone actually been wondering what the guitar is doing there?
Yeah, what about that guitar? What about that shirt?
Well, it works. So, for our final challenge, we want to, a big part of metal music is having a good riff. Like the good part of rock is always the riff part, that's the energy part, that's what you want to do. So what we're going to focus on is using data science to kind of show us what a good riff would be to include on our album. So the way we're going to do that is it's very difficult to train a machine to listen to music. It doesn't understand music. It needs to have numbers. So what we're going to do is we're going to get some music in and create a spectrogram. Does anyone know what a spectrogram is? Any audio people? It's basically a representation of music visually. I'm going to look one up. This is a spectrogram, which is a very long one, of the song Aces High by Iron Maiden. What this basically shows you is the energy that goes into the song and gets basically blasted out of your speaker. So it's kind of like an energy frequency kind of table. But this we can give to a machine to learn, because now we have an image. And if we have an image, we can train a machine to decide, is this metal enough for us, right? So what we're going to do, I need to go to the correct folder, is we are going to record some music. And for that, I need a volunteer. Is there someone who can play guitar? And I know nobody raised their hands, but I was pointed that there was someone in there that could play guitar. Am I wrong? Everyone's getting shy. You can win an awesome Metallytica t-shirt if you come here and play guitar.
And if you come in the next 15 seconds, we give you also 2 stickers.
2 stickers. And we only need like 10 seconds of audio.
These are limited edition, so.
Yeah, there are only 5 in the world. And if you play really well, you get a sweaty one. Anyone? Nobody?
Don't be afraid.
You need to play a melody.
Yeah, it doesnn't matter. Anything.
Anytime.
Then I don't mind.
I'm gonna see. So this is a guitar. I'm gonna check if it works, right? You can sit and you can just play something, and I'm gonna yell, right?
Okay.
So I can record it. There are only 2 rules of songs that are forbidden. That's Nothing Else Matters and Stairway to Heaven. Those are not allowed.
Smoke in the water.
Smoke on the Water is totally fine.
That's too much to ask, but
So you can play whenever you're ready.
yeah.
1 second, 1 second. It doesn't pick up the sound. Oh no.
I should have warned you.
Yeah. It doesn't matter. Play.
Wow. I'm not gonna win the music awards.
That's enough. You get the t-shirt.
Okay.
You get the t-shirt.
Thanks, man.
We only have XXL if that's no problem. So what we got here is a sound file, what we just played. So I'm gonna see if this works. Oh, we don't have audio out. Let's see if this works now. You heard him play, okay? I don't know why it doesn't matter. Anyway, so I'm gonna save this. I'm gonna save it as an MP3, and I'm gonna save it in my raw folder and call it clean music. Save. All right. Yep. So I got basically the thing that he just played here. This is still not, a machine cannot detect anything from this. So what I need to do is I need to convert it into spectrograms. And to do that, I created a PowerShell script. Because PowerShell is awesome. Does anyone use PowerShell here? Yeah, PowerShell is awesome. What this will basically do, it will first create a mono file that isn't really necessary because it was all a single channel, but else you can create a spectrogram. And I'm going to call a special program that's going to convert the whole MP3 into a spectrogram. So that visual representation of the song. Then I'm going to kick off a Python script. And the Python script is going to take that entire spectrogram and slice it into chunks of 128 by 128 pixels, which is approximately 2.13486 seconds. Yes, it's very important information. Because if you do an entire spectrogram into the model, it's going to train forever because, you know, you've seen how big the spectrograms are. They're huge, so it's going to take a long while. So I'm going to run this code. It's going to be really quick. It created 5 spectrograms, which I have in this folder. This is the entire spectrogram bit, and these are each slices. And as you can see, you immediately see a bit of the energy when he strummed his chords, which would probably be a bit this and this. So this is the energy that's transferred and recorded. So we can actually train a model on this. And that's the next thing I'm going to show you, is the Metallymeter. Again, I'm going to import all kinds of libraries again because we need them. And I'm going to do something new right now. I'm going to define a model which is a neural network, and it's called a convolutional neural network. And what a convolutional neural network can do, it can basically detect shapes on images. And very simply, the way it works is you have the image of 128 by 128 pixels. It will create a little box called a kernel on top of the top left corner and detect all the pixels inside that box and then move to the right, move to the right, move to the right, till it's gone across the entire image. And each of the calculations inside that kernel gets a certain number. So if you take, for instance, an image of a banana, and you would train it, the model, on all images of all kinds of bananas, and then you show it an image of a person holding a banana, it can actually detect the banana based on the shape, because the kernels move over the banana. The same, more or less the same numbers come out of each of those little boxes, and you get a result that is a positive for a banana, in the best case. What we're doing in this one is that we're taking it even further. This is what they call deep learning. Has anyone heard deep learning? It's a new hype word. Data science isn't cool anymore, but deep learning is. This is just deep learning.
Has anyone heard of shell learning?
Shell learning. Seriously? It doesn't exist, right? Or you're going to tell me it exists, kinda. So what we're doing here is, this is all boring stuff. We're defining convolutional layers, which basically mean that every time we take that little kernel shape that moves across, we're going to zoom in deeper and deeper and deeper. Kind of like Inception, we're going deeper and deeper for the calculations. So I'm going to define our model, and again, I'm going to load our pre-trained model. Because what I did is I trained the model on data that I flagged. And it's in the other folder. I can quickly show you. Is that there is a model here that I trained on all kinds of music. Let's see. Some of these songs. Forgot About Dre, by Dr. Dre. Really cool. Billie Jean by Michael Jackson. And basically I labeled each song, is this metal or not? So in every area I labeled, is there something that's metal inside this area? There's also music like Creeping Death from Metallica, which is a metal song, and we kind of labeled each part, this is metal or not. Because you need to have a labeled data set for the model to train. It needs to know, am I predicting correctly if this is metal or not? I trained it, it took quite some time, so I'm not going to do that now. But now I'm going to get some data in. So I got my trained model in. I'm going to get the slices we just generated from the live spectrogram slices that were kindly played by our lovely assistant. And we're going to see if we can predict if it's metal or not. So we got the slices in, predict. And here we got for each the different chances that it's metal. So in this case, from start time 0 to 2.56 seconds, there was a 99% surety that it was definitely not metal. It was also not metal in the second slice. It was like, it was metal in the second slice. It was 48%, so we actually created a riff that was pretty metal. And also some parts that weren't metal, and it wasn't really sure in these two if it was metal or not. So how metal is it? So that's the part of the metallometer. This song scored a 60 on the metallometer. Do I see a mosh pit forming? So yeah, that's basically how it works. We can also, should we try to see if we can generate a really metal song? What do you think?
Yeah, sure.
Yes.
I mean, it's metal. I can't play guitar, so it doesn't even matter what I play. It's still metal, right?
So can we go up?
Can I do Nickelback?
Can we go up to
Yeah,
70?
we're gonna go up. I'm
Alright.
gonna try. I need to open the crazy data stuff again.
Can anybody play? Which is on the blacklist?
Nothing else matters. Can you press the record button, Tomas? The record button.
Oh, great. Sorry.
Does it record anything?
No.
Because the volume's up. Does it record anything? Cool. All right.
Can I open it?
Yeah, you can delete that. So we're not gonna do. So for this special occasion, I'm going to switch from the normally clean music. I only play chord music. Beautiful. To you might want to close your ears. To more a style that befits a Slayer like. Yeah. That's all I ever wanted to do when I was a kid, you know, like. So let's give it a try, okay? Do you know a song by Slayer that we could use a riff from, or do I need to improvise something? Or?
Something Angel of Death, maybe?
Or
Or the guy can tell in the audience any favorite songs from Slayer?
do you have any favorite Slayer songs?
Angel of Death is fine.
Oh, I can do Angel of Death. Okay. Now you see why I'm a data scientist and not a rock star. So we got a lot of noise here. I'm gonna delete all of this because this was all trying out. It's not interesting. Come on, hurry up. I only want this part. Again, I'm gonna save it as an MP3. And first I quickly need to do a cleanup. So all the slices of the previous one are gone. And I'm gonna call it Rico. Cool. And I'm going to create the slices again. So we got a nice 4 slices of the spectrograms. And as you can see, the energy levels are a bit different than the previous one. You can also see that I suck because ideally this should have been like almost a straight line, but that doesn't really matter. We're gonna load it inside here. I'm gonna clear all outputs. So we already have our model loaded and everything, so the only thing we need to do is get in the new slices. Here we have Enrico. We're gonna predict, and we're gonna see which parts were the most metal. And as you can see, this was definitely very metal. Wow. Yeah. So how metal was it? It was the loudest, nastiest metal ever. So we won by 100 on the 100 scale, man. We rock. I said we were gonna start a metal band, man. Any questions on this?
Yeah, how long did you practice?
Be honest. Yeah, let's be honest. It wasn't more than 5 minutes, really. Because you saw that, right? I don't play well under pressure. Really. All right. Let's see if this works. Yeah.
100%.
We had that going on, man. With this was our last example. I'm sorry, we could have done more, but you all want to go home eventually. So these are some resources. We've got a Crazy Data Science Twitter handle, and we've got Crazy Data Science YouTube channel. And we have 4 videos up right now that show you some of the examples we've shown you this time. The metallometer is on there, but there's also stuff like how we're going to analyze Slayer lyrics and finding Wally automatically using a webcam, which is really funny. So if you're really bored and your kids always ask, Dad or Mom, do you want me? Can you please help me find Wally? Do the book in front of your webcam and it will automatically detect him for you. Because data scientists are lazy. Those are all on the YouTube channel. We want to thank you for attending, and we hope you enjoyed it. If you enjoyed having us, please subscribe to our YouTube channel where we try and regularly produce new content. We're working on the Trump bot right now, right? I'll let you think about that, what that means. And we're still looking for guitar players, bass drummers, singers, and groupies if you also. So thank you.
Yeah.